This video, we're going to show an important theorem or fact when it comes to automorphisms. For the record, an automorphism of G is nothing more than an isomorphism from G to G. Many times you may have an isomorphism from G to, say, G prime, where G and G prime are different. But when G and G prime are the same, that is, when you have an isomorphism from G to G, we don't say that. We say it's an automorphism of G. In this video, we're going to prove the fact that if G is a group and phi is an automorphism of G, then if A is in G and it has O of A order, then phi of A, or the order of phi of A, is the same as the order of A. If you like watching mathematical proofs like this, you should consider subscribing to my channel, as this is what we do here. Okay, so let's get right into it. Suppose that the order of A, denoted as O of A, is M. That is, A to the M is equal to 0, while if N is positive and less than M, it's an integer, A to the N cannot be E. That is, this M is the smallest positive power that when you raise it to A gives you E. Now, we know that phi of A to the M is phi of E, which equals to E. Since phi is going from G to G, they both have the same identity element. That's why I'm not, for example, calling that E on the left E prime. Okay. But now this here is the same as phi of A, the whole quantity raised to the M. That means if I multiply phi of A by itself M times, I'll get E. The question is, can I do it for a smaller n, smaller m? So let n be as follows. Let n be such that 0 is less than n and n is less than m, such that phi of A to the M is equal to E. Okay, so we know that E, just recopying this, E is phi of A to the M, but that's phi of A to the M. And it equals E. Well, the only thing that gets mapped to E is the identity element. Okay, that's the only thing that gets mapped to E. Phi of E to a power is equal to phi of E, which is equal to E. What I'm saying is, the kernel of phi is the set of all elements, is E. The set of all elements that equal E. And E is equal to E to the 0, E to the 1, E to the 2, and so on. Okay, so now, since n is less than m, it must be that since phi of a to the n is equal to phi of a to the m, that implies that a to the n is equal to e and a to the m is equal to e. But that's not true. You can't raise a to the nth power and get e. M was the smallest positive integer, and n is bigger than 0, making it positive. So there's a contradiction. That implies that this m right here was the smallest such m. That implies that the order of phi of a is also m. Okay, we know that when you raise it to m, phi of a raised to the mth power is e. But we can't just blindly make this statement. It has to be the smallest such positive number. And I show that. I tried real hard to get a smaller number, positive number, smaller than m, and contradiction. That completes this proof. Let me get rid of is that side work? This is our side work. If you like watching math proofs like this, consider subscribing to my channel. Please click the like button. Tell your friends, family, and enemies about my channel. See you guys in the next video. Watch and learn.